Welcome everyone. Today I'd like to exhibit a demonstration that we have put together to show you in practice how you can save power and simplify thermal management in high reliability processing systems so that you can see with your own eyes the possibilities that we offer at Teledyne E2V. At Teledyne E2V, we receive frequent customer requests to deliver power-optimized processors. Sometimes the need is to reduce power consumption because of power supply sizing or because of limited power available. In drones application, for instance. Sometimes the requirement is of compactness because it's not possible to cool properly the components within the given volume constraints. A few months ago, we published a white paper that explains in detail how we managed to reduce by 46% the power consumption compared to the datasheet power consumption on a specific customer application. Today, I'd like to show you in practice the benefits that it brings. Before going in the details of our demonstration, I would like to give you some details on how to analyze processor power consumption. Processor power consumption is typically split between what we call static power consumption and dynamic power consumption. So on this graph, dynamic is the yellow one and static is the blue one. What you have to know about static power consumption is that it more or less corresponds to the leakage current that is flowing through the device as soon as you apply power supplies on it, even if in reset state and even if there's no clock applied. Static power consumption evolves non-linearly versus temperature. And what's interesting about static power consumption is that it's not repeatable across parts. That means it's possible to select parts that have lower power consumption. Dynamic power consumption, on the other hand, is more or less independent from junction temperature, but it is dependent on CPU load, platform and CPU frequency, and the types of peripherals that you are using. That means that dynamic power consumption is dependent on your application. Now, let's go in the details of our demonstration. We have two single-board computers that have been designed by our partner Syntex. On each single-board computer, we've got a T1042 processor that is a quad-core PowerPC architecture that can run up to 1.5 GHz. The left processor is a standard processor that is running an application that loads the CPU at 100%. The right processor is a Teledyne E2V power-optimized processor that runs an application that loads the CPU at 50% load. We've got an infrared camera from our colleagues at Teledyne DALSA that is looking at both processors simultaneously, and the camera picture is displayed on this screen. So we've got still on the left the standard processor and on the right the Teledyne E2V power-optimized processor. So now looking at the details of the results. So if we look at the left processor, we've got a temperature, the heatsink temperature is around 71 degrees and the right processor is around 59 degrees, so around 12 degrees of difference. As you've probably realized, the junction temperature is actually higher, and this is what we see on the terminals. We see that the processors are between 90 and 100 degrees of junction temperature. So there is still a very big difference in terms of junction temperature between both processors. Looking at the junction temperature and the board power consumption, so board power consumption, we've got 10 watts on the left board and we've got around 9 watts on the right board. And if we look in the details of the processor power consumption, which is of interest here, we see that the difference between the two processors is between 1.5 to 2 watts, which is quite a very big difference. So, to conclude today, what we have shown is how it's possible to reduce power consumption in your high reliability processing system thanks to our products. What we have shown is when keeping the same heatsink, it's possible to reduce power consumption. But it's important to note that it's also possible to reverse the approach and to keep the power consumption fixed and to reduce the heatsink size. If you want to get in more technical details on how power-optimized processor products can help you, don't hesitate to have a look at our white paper and to get in touch with us.